Beautiful. So let me just double check the pages. Why did I give you pages that don't seem to be the right pages? Okay, so 441. Oh, no, maybe it is okay. Yeah, okay, it's good. 441. All right, so I'm just gonna hold it for a second up. You guys all have the textbook. All right, so that is page 441, and you're gonna go for 9 pages until 450, until you get to the z-scores. So as soon as you get to the z-scores on page 450, you can stop. And I will also post one more, a 3-page reading on chi-square test. Again, you don't need to worry about how it is calculated. All you need to know is that this is what you will apply for your data, and you need to understand why. And that's what we will do today. Your activities for next week are not posted yet because it's mostly stats, and I need to figure out what to give you not to overwhelm you. So I'll post them tomorrow. So hold on to doing any activities until tomorrow. All right. Okay. Next week, and then again, this is a preview. I'll repeat it on Thursday when you guys are supposed to be here. We will start with your data analysis, which means that Thursday, November 12th is going to be our hands-on class on data analysis. You have to have your data not only collected, but already input it into an Excel file. Or you can use Google Sheets, whatever it is, they are identical. So we will do data analysis in class. So if you don't have your data by next Thursday, you're in trouble because you won't have anything to work with. Okay? So before we move on to chapter 8, does anybody have any logistics questions that I need to address? Of
Hi,
course you can.
Professor. I had a question.
Go ahead, Seaver.
Maybe we can speak possibly at a break, but our group, we were actually able to collect our data and also fill out our observation log. It was my bad because I told us to hold off and do anything because I figured we could use the opportunity to meet on Tuesdays to maybe ask you, we basically have our data, 40 observations on a Excel sheet. Is that what other groups are technically sending you?
Well, you don't really have to send me anything, but you need to have it posted. So, well, posted, you can have it available. If you want me to have a look at it just to make sure that that's how it should look like, yeah, then just send me an Excel and I'll look at it. But
okay, great.
All you need to do is to have it next Thursday so we can do the chi-square together.
All right, understood. Thank you.
All right, guys. Any other questions? I'm going to take a very short 1-minute break and come back. So stay put. Yeah. All right, let's start. Oops, where are we? Here we go. There it is. So again, I'll repeat all of that on Thursday, but if you are in touch with your group mates that are not present, just, talk to them about being there on Thursday so we can continue writing. Okay, so chapter 8, like I said, is not particularly exciting. It's a little dry because now we will be talking about association claims and how we interrogate their validities and also other things that have to do with analyzing data that come from association claims. Now, why it is important? Because what you are doing is also an association claim. So the reason why you will be doing a chi-square has to do with your variables. And that's where I would like to spend a bit more time yet again today, because you guys continue to struggle with the types of variables, scales, and levels. So the question that you had on your quiz 4 was something about tennis experts playing and what was measured the reaction time in how they bounced the ball. So you had 3 questions. You had to say what kind of variables these were, which one is predictor, which one is a response variable, the types, continuous versus categorical, which scale they should be measured on. And we know there are 4 scales. And then the last question was a new question that had to do with which data analysis, which statistical test you would need to use to analyze the data. And like I said, I've graded all your quizzes. There is only 3 people who answered this question correctly. Kudos to you guys. Everybody else, we need to continue working on the variables. What's especially sad for me to see is that you still, not everybody, but many people still struggle with which one is the predictive variable, which one is a response variable. Now that is not good. We have to fix that. So I may post a bunch of exercises for you that you should do. Okay, so let's start with our usual favorite flow chart. I hope you have it nearby. I would suggest that you actually post it on the wall. Where's my wall? Right here. Okay, and look at it because it will help you see where we're going. And I already told you that we are rapidly approaching the end of the actual material from the textbook. Not that there are not enough chapters, there's plenty of chapters. We just don't need them. For example, the next one, the chapter on multivariate correlations, multivariate association claims, is not something that you will be expected to use. Well, unless you go to like master's program, maybe over there, but not at the undergraduate level. So this chapter is sort of a wash. We don't really need that. And in terms of part 5, which is the causal claims, all we really need to do is talk about the simple experiments and some of the confounding variables. And anything that's above that, which is experimental with more than one independent variable, quasi-experiments and small n designs, this is beyond our head. When you get to the labs, after taking 266 statistics, you may need some of these statistical tests depending on which lab you're going to take. All right, so that is what's going to be the end, and that's going to be the 2 chapters on experiments, really, because what we're doing next week is descriptive statistics, and the week after we're doing more of APA stuff. And then we will be done by just talking about experiments. So this is where we are in terms of how we progress. We started, remember, with the idea, and you had that in your observation plan. We moved to generating a hypothesis, and I asked you to do 2 predictions based on the 2 levels of your predictive variable and 2 outcomes of your response variable, giving us a 2x2 contingency table design. And that's the design of our correlational study. And you are using observation, despite the fact that some people just continue to send me stuff that had to do with surveys. No, no, and no. Next time, when our life is less in upheaval. You already chose your participants. The method, like I said, is observation. You define the variables because I asked you to provide them explicitly in the observation plans. And of course, choosing measurements has to do with the types of your variables. So now most of you are in the conducting study phase, right? And a couple of people are already done with that. So that's my question to all of you, and particular groups that have finished data collection. What goes into this box? What's the next step in our flowchart of the research process? You can either unmute yourself or type it in the chat. Collecting data, that's what we're doing right now, Rita. What's the next step? Conduct study and collect data is the same. Analyze the data, yes. Excellent, Seaver, exactly. We are going to analyze our data. I'll come back to your question, Tara, in a second. Oh, of course, I have to close this. All right, analyze our data. Okay, now the next question that is a question for somebody who can predict or guess what's going to happen at this next step, after which there's only 2 steps left. So what do you think will happen once you analyze your data? Interpret results? Yes, Rita, it's a part of that stage. So interpret results is in that box, but the box is a bit wider or broader than just interpret the results. Jenny, I'm sure you know the answer. Or guess. I'm not sure. Okay, well, let's think about your assignment number 2. Once we do our data analysis next Thursday, what's in store for you for assignment 2? What do you have to do next? Yes, you will be yes, lab report, right, Jenny? And so what will you be doing? You will be not just interpreting the results the way Rita says, because that's a part of that, but you will be writing, right, your lab report, your essay, your experiment, your results. And the reason why you have to say that you will be writing, because you have to share your results with the world, right? Okay. And the last, this one is sort of optional because it's presentation of your results. Like if you go to a conference. And now another good question, and I'll stop torturing you. Who can, and that's going to be a really good question, good answer if you can figure this out. What's going to be in the very last box here? That's really a true A grade question. Would anybody try to guess? Submit. Well, you know, presenting and submitting, Jenny, I would say that's almost the same. No, this has to be something beyond writing and presentation. And I will give you a hint. It's something. Revision, yes! Remember, chapter 1, okay? We have, let me see if I have this figure quickly to show to you, right? Okay, do you guys remember this? I can't see myself, that's bad. Remember this figure, right? Okay, you go through the research process and then you say, oops, I need to revise my theory and I need to design a new experiment. Oops, and you're going to go through this data theory or theory data cycle forever and ever and ever. That's why psychology is so beautiful, because it's endless, and it's also so difficult because it is endless. Okay, good. Jenny, Siver, and Rita, perfect. You guys have done an excellent job. All right, so we are talking about bivariate correlations. Now you have to be really careful. From this point on, you cannot call anything an experiment unless it is an experiment. And the experiments are only causal claims, which is not what you guys are doing. One of the goals of assignment 1 was perhaps for you to find a journalist piece where an association claim, the one that we're talking about today, has been made into a causal claim, which is very different. So here, association claim is always two variables. So think back to what you're doing for assignment 2. You have gender and mask wearing, or you have, child stopping at the crosswalk. If the child is walking as a single person or in a group, and so on and so forth. These are all your variables, okay? The point is why these are correlational designs. It's that these variables are measured versus manipulated. So for correlational designs, association claims, the variables are always measured. We have no control over them. We cannot assign somebody randomly to be a man or a woman, or to walk alone or walk in a group. That's what people do. Use the phone or not use the phone. This is their choice. We cannot manipulate it. To a certain degree, there are ways of going around that. But typically in association claims, we're just bystanders. We only see what's happening. We cannot manipulate that. And that's the crucial difference, which means predictive variable is measured, response variable is measured, and all we can say that they are somehow linked. That's a correlational design. They correlate, right? They relate. While in the experiment, one is the independent variable. That's the one that's manipulated, that affects the dependent variable that is being measured. Okay? We'll continue to do that when we move to chapters 10 and 11. Okay, we are using the same group of participants. Okay, so we could, depending on the predictive variable, it could be, of course, different genders, for example, different ages, but it's the same sample. We're not switching. And the way we present the data, note that presentation and analysis are two different things. You're presenting a data usually in a graph, or the way we call it in psychology, in a figure. But figure is not equivalent to the analysis. This is just a visual representation of the data. You need to actually do statistics to analyze your data. Again, this class does not presuppose that you know a lot of statistics, but it presupposes that you can learn a few things like calculating means and standard deviations, simple things like that. The real statistics will come in 266. And I have to tell you that I just observed, because that's what we do, we help each other. I just observed 2 different sections of 266. Now, people who are struggling in these, students who are struggling in these sections are the ones who did not have a good preparation until 1. It was very obvious to me. So please, I continue to ask you to get involved with the course, read the textbook, and learn your variables. If one thing I can teach you by the end of this semester is to be comfortable with your variables, I have done my job. I will rest my case. Okay. Now, the illustrations from chapter 8 come from these 3 papers, and we'll go through each of them for a few minutes and try to, again, talk about variables and how one would go and analyze these are all association claims. Okay. So let's start with the first one. This is a continuation of the paper that we discussed some time ago, maybe a couple of weeks ago. Actually, yeah, because we talked about an observation and we used Mel's study, not this one, but the one before that, where the participants wore a little digital device that recorded what they were talking about every 12 and a half minutes for 30 seconds. And the hypothesis was it's believed by many people that women are more talkative than men. So the idea behind the initial study was to see whether this is true, whether actual data, when collected from men and women, will confirm that hypothesis. Does anybody remember what happened after the study was finished and data were analyzed? What was the upshot? Oops. So the hypothesis was that women talk more than men. And what did they find? Did they confirm the hypothesis or did they disconfirm the hypothesis? Okay, there was no statistical difference. Jeremiah, now put it in terms of hypothesis. Did women talk more than men? How would you answer that question? No, Rita. No, it was a null result. That means that 16,000 words that women on average were. Uh-huh. Okay. Vanessa, I see you. All right. Women on average spoke 16,000 words and men 15 and a half. If there was no difference, this means that women and men talk about the same. Okay. So this is the continuation of that study. Obviously, they collected all this enormous amount of data and they can do something else. So now, who can tell me by looking at the title of the paper, where is the claim here?
I guess the claim is that the more substance a conversation has, the happier the participants.
Very good, Seaver. But now all I'm asking you is to find the claim in the title. Can you do that?
Okay.
Without paraphrasing it, just give us the part of the title that is the claim, because the claim is in the title. Cholani, can you do that? Can you read the title and figure out where the claim is? Very good. Well-being is related to having less small talk, right? That's the claim. So we have the two variables. One variable has to do with the type of talk you're doing, right? The other one has to do with how well you feel or how well-being you consider yourself to be, right? And we have is related in the middle, right? Which is an association verb. Okay? Making this, so the first two words are just there for aesthetics. They kind of liked it, eavesdropping on happiness. That's sort of catchy, right? But who cares? What you care about is this part that Cholani was very good at spotting, right? Okay, here is your association claim. And that's how I would like you guys to try. And then Rita did that too. Okay, good. To think about the titles of your assignment too. You have an association claim. You have your data. You can write it up as a claim. Good. Just to remind you, this is how the authors took care of about operational definitions of the variables, right? Both of them are measured. So the first one was level of happiness. Well, we already talked about it. I mean, how do you operationalize a conceptual abstract variable like happiness? Well, I mean, you can give people a scale. And this particular scale is called satisfaction with life. So you're going to answer these questions, you're going to get a score. The happier you are, the higher the score. I guess that's the way it will work. And the second one is a little bit more engaged because you have to think about how will you measure depth of a conversation. Well, if you talk about weather, is it deep? Probably not. If you talk about perhaps some feelings of people in the movies and some drama, that probably is deeper. Again, you need to have an operational definition of what you mean by deep talk versus small talk. All right. So they took all the amount of data that they received for each participant. Remember, there weren't that many of them because this is a very intense data collection. And they had their research assistants, like you guys, listen to these conversations and code them by saying weather. And this part of a conversation is about feelings of whatever else they might be talking about, and that's deep. And so you will then calculate the percentage of time out of the entire time the person talked that was spent on small talk. That is things that are very simple, right? It's things that don't require any thinking or any particular engagement. And this is approximately what it will look like. Note that this is the table from the textbook, and these numbers are not real numbers. They're just invented for the purposes of this illustration by Morling. So here is person A, right? Person A spent, so here they switched from small talk to deep talk. So person A actually likes philosophical topics. She spends a lot of time, in fact, 80% of the time in conversations talking about important things. And then she gave herself a well-being score of 4.5. Now compare this person to person ZZ, who only spent 16% of her time in a deep conversation, and then she rated herself as not being particularly happy, right? So here is one variable, here is another variable. So now the question to you, and I'm going to try to ask you to do it quickly. And if I don't see an answer, I'll call on somebody. The question is, out of these two variables, which one is the predictor variable? That's the one that affects the behavior that we are measuring. And which one is the response variable, the one that represents the behavior that we are interested in measuring? The names of the variables are in front of you. All you have to do is to decide which one is which one is the predictor variable, which one is the response variable. Okay. I'm not sure, Seaver, that. Okay, so let's make our life easier. Let's put the predictor variable at the beginning of the sentence. It's the one that affects the response variable. So what I want you, everybody, not just Seaver, in the chat, type in what the predictor variable is and what the response variable is in that form. Go on. I want everybody to participate today. Okay. Well-being score, deep conversation, percent of conversation, well-being. Good, good. So who's, okay. All right, good. Stop. Let's do the following. Clear this, close this. I'm going to open our participant manager screen. You guys do the same. And let's go to our favorite toolbar. So my question is score on well-being a predictive variable? If you think that it is, click yes. If you think that it's not a predictive variable, if therefore it is a response variable, then click no. Good, good, very good. Yes, no? What if I'm making you confused? Okay, good, no? Think about it. Well-being score, is that a behavior? Or is it the factor that affects the behavior? What do we care about in the study? Do we care about well-being or do we care about the quality of conversations? Okay, I'm going to clear that and ask you to think. What are we measuring? What do we care? Well-being, right? We want to make sure that people are happy. Well, we are measuring happiness. And the prediction is that this happiness can be affected by the quality of conversation. Yes, Cholani, perfect. So the one that affects the behavior is the predictive variable. It predicts behavior, right? So let's do it again. Is score on well-being scale a predictive variable? Yes or no? Yay, now we are getting there. Of course it's a no, right? It's a response variable. It's just presented here in this table in the order that's the opposite of what we would like it to see. And our predictive variable is the quality of conversation. If you're talking about high things, things that make you think, you feel more fulfilled, you feel more happy, you feel like you're doing better. So percentage of conversations rated as deep talk or small talk is the predictive variable, and score on well-being scale is the response variable. So who is confused? Do you understand the difference between predictor and response variables? And that was one of the problems with that question on your quiz 4. So we were measuring expertise of tennis players on the speed of their reaction, well, their reaction time when the ball is coming their way. Which one is the predictive variable? Which one is the response variable? Again, you can start with asking, what do we want to measure? What do we want to know? We want to know with speed depends on whether you're an expert or not, right? So which one is the predictor? Which one is the response? Jenny says, predict whether you're an expert or not. Very good. Level of skill and responsive speed. Yes, perfect, perfect. So you need to be very careful. The problem with the association claims is the variables are kind of, they can be sort of similar in the way that both of them can be measured, because both of them are measured, right? Good. So now let's see if we can try this little exercise. All right. So now we have identified the deep talk as our predictor variable and well-being as our response variable. So my first question is, think about deep talk. What are the levels? How many levels are we talking about? 2. Yes, Jenny, perfect. What are the 2? Stop, Jenny, don't say anything. Stephanie, what would be the 2 levels? Jenny is correct. Stephanie, I'm asking you only about the first variable. Why are you putting score in there? Score is the response variable. My question is about the predictive variable. Oh, wait. Okay, I'll wait. So what are the 2 levels of the predictive variable? And the predictive variable is quality of conversation or depth of talk. So what are the 2 levels? I'm confused. I'm sorry. Okay. Maybe I'm not explaining it well. I don't know. Jeremiah, would you like to try to explain the difference between the predictor and the response variable? I guess it may be too noisy in your place. Who would like to try to do that? Victoria, how about you? Can you explain in your own words? Okay. That's all right, Jeremiah. Victoria, can you explain in your own words what is the predictive variable and what is the response variable? No, Victoria? Thomas? Okay, Victoria says no. All right. Who can do it except for Seaver, who has already gave me a suggestion? I would like somebody to do it in your own words, not in my words. Thomas? Edgar? Sadiru? Didi? Anybody? Let me repeat the question. Can you explain the outcome, which is also, Jeremiah, known as response? So predictor is used to estimate or predict the response. So if you exercise, your health will be better, right? Maybe it predicts the value of the variable. Yeah, because both of them have to covary, right? So if you say that my predictive variable is the quality of conversation, what could be 2 simplest levels of that variable? How can we measure quality of a conversation by just using 2 categories without anything very deep? Okay, that would be a different variable, Rita, because that's not about quality. My question is about quality, not about volume. Right? So more talk doesn't necessarily mean deep talk? Deep talk or surface talk? Right. Very good, Tara. Or, you know, deep talk and small talk. So these are the two simplest variables. So the prediction is that something will happen to how you feel depending on whether you're doing deep talk or small talk. Maybe you disagree with the findings that deep talk makes you feel better, but that's sort of separate from the question, which one is the predictor, which one is the response. Perhaps what confuses you is the fact you could say, well, wait a minute, couldn't we flip them around? Could we say that if you are feeling well, if you feel that you're happy, that you will be more likely to be engaged in a deep talk? When you are anxious like we are today, maybe we're more likely to engage in small talk. So that is the issue with the association claims, because there is no that easy way to identify. I mean, you can play it the other way around. When you're doing an experiment, if we were, here's a very simple exercise. If you guys feel stressed today, okay, if you have a pencil or a pen next to you, I have a pencil, right? So take this pencil and hold it in between your teeth like this. All right? All right? Hold it for a few seconds. Presumably, this is what clinical psychologists tell us, if you create a sensation of smiling, because your muscles now create a smile, it should slightly improve your mood. So if you pretend that you're smiling, you will feel better even if you don't necessarily have any reasons to feel better. It's just because this is what we call embodied cognition. Our body helps us with our cognition. All right, so here they had a hypothesis that if you talk about deep things, you will feel better. So this if, then, whatever is if is going to be the predictor variable. Whatever is then is going to be the response variable. Does it make more sense now? Victoria, you in particular, and Stephanie, who was confused. Did you see the difference between predictor and response variable? We're not going to go too far today, but that's all right. Okay, good, all right. So who can answer the question? We already basically did that. The deep talk variable, the predictor variable, is it categorical or is it continuous? What are the two levels? Tara just typed them for us. Deep talk and surface or small talk. What are these? Is it a continuous or is it a categorical variable? Categorical, yes, thank you, Seaver. Categorical, thank you, Lewis. Beautiful. Now, somebody else quickly, what would be the scale that we would measure this variable on if it is categorical? What are the two scales that we use? Nominal, thank you, Jenny, beautiful. Let's move on to the next one, which is the response variable. Response variable is the behavior that we are measuring. We are measuring people's happiness. We're asking them to say, how well-being do you feel today? And what are the responses? Okay, well, looking at the table, they say they rate themselves as 4.5 or 3 or 4.9 or 2.8. What kind of variable is that? Is it categorical or is it continuous? So if I go back to the table, okay, this variable, is it categorical or is it continuous? Well, look at the values. What are they? Continuous, right, Thomas? Because these are numbers. Note that although we talked about quality of conversation as having two values as deep or small, they actually measured the percentage. So now we actually have to change what we thought this variable was. I'm going back to the predictor variable. Look at the values. In terms of percentages, is it categorical or continuous? Right? These are numbers again, right? These are percentages. So is it a category? In the way they presented it as percentages, is it a categorical or continuous variable? Continuous, yes. Thank you, Jenny. So now coming back to where we were a second ago, we answered these questions, and the scale, Jenny, could you quickly give me the scale for percentages? Ratio, fantastic, because there isn't a zero, there's a 0%. That is, there was no deep conversation. And the question is statistics. When you read this chapter, I guarantee that nobody figured this out. The statistics, that the statistical test that you have to do, depends on how you answer these two questions. What are the possibilities? Well, remember, it's a 2x2 contingency table of sorts. So you can say, my predictor variable is categorical and my response variable is categorical. That's what you guys are doing, right? You have age, female, gender, male, female, and whatever people are doing. They're doing something, yes, they're not doing this, no. So male, female, yes, no. Both are categorical variables. And this, write it down, take a picture, do whatever you want, but imprint it in your brain. When you have two categorical variables, not the only, but the main statistical test that you should do is chi-square. That's it. Chi-square does frequencies. Now, if you have a continuous variable, which is what we have here, now you can do a linear regression and it will be represented as a scatter plot. So knowing and what if you have categorical and continuous, which is what we will see next, then it's not going to be chi-square and it's not going to be regression. It's going to be something else. So that's why I keep insisting that you learn these variables, because if you know how to do that, you will sail through 266. And you can come back and say thank you to me, and I'll be very pleased to hear from you. So here we have two continuous variables, and we will be doing a scatter plot and calculating correlational coefficient. There it is. Note that when we're doing correlations, this is a mathematical correlation, okay, we have to answer the two questions. What is the direction of the correlation? Well, here's the line, right? The direction is positive, right? Because it's going up, the slope is going up. And what is the strength? Well, the strength depends on how far these dots are from this correlational regression line. So for example, these several, I'm just looking in the middle, are very, very close to the line, but like this one is way too far above, and this one is way too below. So it looks like these dots are sort of scattered. And once we calculate, I think it's actually, oops, this is not the right number. It should be 0.28. Okay, because correlation is bound between 1 and -1. Okay. So if we have this number 0.28, you would say, well, is this relationship strong between these two variables? So if the line were like this, I'm going to do my best rendition. Okay. If the line were like this, it would be a perfect correlation with R of 1. Let me now clear that so you can see that. If my line were like this, it would have been a perfect correlation of -1. But we have something that is, again, for whatever reason, I forgot to put a decimal here. All right. If this R is 0.28, is it a strong relationship? Is it a weak relationship? You learn about it in 266, but we have something known as Cohen's d, which was invented not that long ago, about 30 years ago by Jacob Cohen. And all we need to know is go back to this table by Cohen, all right, and it will tell us. So if our R is 0.2 or below, it's a small effect size and the relation is weak. If it is between 0.2 and 0.5, it's a medium effect size, so the variables are stronger related. And if it's 0.8 or above, which rarely but happens, it's a large effect size and it's a very strong relationship between the variables. Again, anybody who is curious to know what Cohen's d is, you can read those pages from the textbook. I won't ask you to learn that. It's not a very difficult calculation, and it's easy to understand. As long as you understand, here are a few numbers that might be helpful. Oops, let's go back. Right. So what do we mean by the relationship being weak? Well, if we have the predictive variable like quality of conversation for a small relationship, which is 2.8 in this example, only 58% of the people who did not get engaged in a deep conversation will be below the ones who did. So, and as you can see, this number increases as the effect size increases. All right, that was one example. Let's do another one. This is about multitasking. Now, this one doesn't have a claim in it. It just tells us that there's something about multitasking that they will be investigating. All right, so this is again, the data. Let's look at the two variables because it's an association claim. So here is variable 1. All right. So you ask people to use a questionnaire in which they identify how many times they multitask. It's about media multitasking. That is, you are watching something and you're listening to something or typing something simultaneously. You're watching the box and you are writing your paper. You are listening to some music and you are reading your textbook. All of these are multitasking scenarios, right? So you give somebody a questionnaire and you say, okay, give us your estimates of multitasking and how much of it and what types of media you're using simultaneously. And then they also wanted to know whether people are good at multitasking. One thing is, do they believe that they're good? That's separate from actually measuring this, right? So the multitasking occurrences were measured by this special questionnaire, multimedia something. And what was measured with using a special task, which is very difficult, called OSPAN. They were asked to perform two tasks simultaneously, and the accuracy was measured. Okay. So who can tell me which one is the predictive variable, which one is the response variable? And as soon as you answer this question, answer it correctly, we'll go for a break. Yay. Edgar, do you want to try? No. Didi? Are you guys there at all? I don't know. Um, Cholani, how about you? Would you like to try? Take one of them and tell me what it is. Is it a predictive variable or is it a response variable? Oh wow, I guess there's nobody. Huh. Well, I mean, you don't have to be here after all. But if you don't practice, you won't learn. Louis, how about you? All right, why don't I take some attendance now? Okay, Rita says, score for multitasking frequency is the predictor. Yes, and you're guessing right. Why? Because if you think that you can multitask, you multitask a lot, that's your predictive variable. And then we'll put you in a task where you will have to do things like, I forgot what it was, but let's see. All right, so what did they have to do? To measure frequency of media multitasking, the researchers asked participants to complete a media multitasking inventory, that's MMI, in which they indicated how many hours a day they spent using each of 12 kinds of media: web surfing, text messaging, music, computer video, TV, etc. And also how often they used each one at the same time as doing another task. To measure ability to multitask, they gave participants an O-span task. In this difficult task, people alternately read letters on the computer screen and solve basic math problems in their head. Then prompted, they had to report all the letters and give the answers to all of the math problems they have recently seen. That's a killer. All right, and the response is going to be the accuracy score. Fantastic, Cholani. Very, very good. Let's quickly finish that and then go on a break. And questions are the same as we had for the previous one. Okay, so the ability to multitask, right? This is our response variable, accuracy. Is it categorical or continuous? And what was the scale? Now, think about the key Q. The Q is accuracy. How do we measure accuracy? Continuous, fantastic, said Euro. Right, from 0% to 100%. And the scale, said Euro, is which one? The same scale that Jenny identified for us for the first experiment. It's percentage, right? Is there an absolute zero? Zero. If it is a continuous variable, how can it be measured on the nominal scale? Nominal scale is for names only. Ratio, thank you, Rita and Seaver. Good. So finally, the multitasking MMI inventory. Let's look at what it looks like in the table, right? Look at this. What are these? It's a score, right? And if it's a score, these are numbers. And if they are numbers, continuous, very good. And the scale, Seaver? Think about it. Remember the difference between absolute zero and not having absolute zero. If somebody gives us a zero, really, on that scale, does it mean that this person never engages in multitasking frequency kind of thing? We could make it a ratio, but remember, usually anything that has been invented by people is interval scale. But for statistics, it doesn't matter. What matters is that both of these variables are continuous. And if they are continuous, what would be the statistical test and what kind of a representation will we have? Exactly the same one that we had for the previous study. We're going to have a scatter plot, right? The only difference now is that it's a negative relationship, right? That's why there is a minus here. And it's a negative relationship. That means the more you multitask, the less your accuracy is going to be on this very difficult task. And it's a small effect because it's almost 0.2. So the effect size doesn't matter whether it's a minus. It doesn't matter whether it's a minus or plus. Okay, it's 5:44. Let's take a break until 5:50. Okay, I need to talk to Edgar. Edgar, are you here? While I'm waiting for him, I can ask.
Hello.
Are you here? Okay, good. So what did you decide
I'm honestly not sure because I haven't gotten any response
from any of
from.
them?
Yeah, but so the two things that I sent, I did it all by myself, but
Uh-huh.
I wasn't really sure because I didn't get any input from both of them. They just kind of agreed with me, and we agreed that we would all work on it. And when we were supposed to work on it, I never
Mhm.
got an answer, and they never edited the Google Docs. So I just did it by myself, and I sent both of the ones that I sent to you.
Uh,
But
yeah, and neither of them is gonna work, Edgar. That's my problem. However,
yeah,
I agree with you that this is not a very good situation. I don't want you to be in this situation. Let me, Tara and Norma, are you guys here?
Yes, I'm here. I actually had a quick question for you about the observation plan.
But before we go into your question, Norma is here. Okay, perfect. You guys are just the two of you. Would you be willing to accept Edgar as your partner number 3? He is very, very responsive, I can tell you.
Yeah, that's fine.
Okay, fantastic. Good. So, Edgar, you're going to be a member of group number 2, right? You guys are group number 2?
Yeah.
Norma, is that okay with you? Perfect. So, go ahead, Tara, and ask me your question. And then what you guys need to do, you need to exchange your phone numbers and make sure that Edgar knows what you're doing. So you need to share your observation plan and then get together online, of course, to decide how you'll collect data. Go ahead, Tara. What's the
Right.
question?
Okay. So we shared our observation plan with you, but I
Mm-hmm.
don't know, like you still didn't sign it yet. I don't know if we have to like send it through email or something.
Oh, okay. So,
And you asked me for the to add the a research article, so
that's
I
why. I need a
yeah.
research article from you. So do you have it?
Yeah, I found it. I put it. It's there on the Google Doc now.
Okay. Why don't you send me the information? Just copy it from your Google Doc and send it to me right now. So what I will do as soon as the class is over, I'll look at it
Mm.
and I will send you my approval if everything. I think that was the only thing that was missing, right?
Yeah.
Perfect.
And then also, I know that you already went over how to collect the data on the Excel sheet, but
Hmm.
um, I don't really remember, and I even tried like going back to your recordings, and I
Hmm.
just couldn't find it. So
Okay. So we still have a couple of minutes. Let me quickly do that. So think of, okay, all right, a second. Right. I'm going to open Excel, Tara, Norma, and
mm,
Edgar. You guys watch. Oops. Go away. Mhm. So, okay. Excel. And I'm going to open an Excel that I already have from another group. Doesn't matter. Okay? And I'll explain to you what that is. Open it. And share with you. All right, I'm going to make it a little larger. Can you see?
Yeah, I
Okay,
can see.
good, good. Norma, Edgar, can you see, guys?
Yeah, I could see.
Okay, good. So, Tara, look, column A is your participant number. Now is going to be 3 of you. So how many participants do you need?
3.
It's 3 of you. How many participants do you need as a group?
Oh, 30.
Very good. So each line, Tara, is one of your participants. They're just numbered, as you can see here, up to 28. So 1, 2, 3, and so on. The next column is your initials, so you know who collected the data, right? So it's going to be, you know, TK and ER and NO, okay? The next 4 columns are your variables and their levels, 2 by 2. So remind me what the idea is that you are studying.
It was children like stopping at a crosswalk, or do they stop when they're with parents, like, or a group, like
Okay.
of adults, like
Gotcha.
something like that?
Okay, so we're gonna combine these 2 by 2. So we'll say child alone. Oops. Okay. Child plus adult. Okay, Tara, can you guess what the other 2 will be? So, okay,
Yeah.
let's make it, and we need to, so child alone crossing,
Right.
child plus adult crossing. So what are the other 2?
And then it was child alone not crossing,
Very good. Not,
or
and
well, not stopping.
not stopping, or stopping,
Yeah,
right?
not stopping at the cross.
And
And then child with adult not stopping.
excellent. All right. The other stuff is if you need it, if you need to record gender, ethnicity, observation time, you can do that. But basically, this is it. You really need just these 6. And now you will be observing each of your participants. So here is your first child walking, and you're going to put a 1 or a check mark into one of these 4 cells, depending on what the child did. Okay?
Right. Okay.
You understand why there's only 1 here. So this particular participant that you observed was child by himself, and he did not stop. This one means that the child, oops, a line, I can't even type today, was the child who was alone and he stopped, or she stopped, right?
Yeah.
This one was child alone and that child did not stop. And this one, right, I'm looking at number 17, was child with adult and they did not stop. So you only have check mark on 1 in 1 cell of the 4 columns. Does it make sense?
Yeah, it makes sense.
Good. That's what you need to do. So let me kill that and not save it. Okay, let's go back to where we were.
Thank you.
You're welcome. Here we go. All right. Now, so this second study is just like the first one in terms of data analysis because both variables are continuous. Let's move to our third study. Okay, and this is Cacioppo and colleagues on whether if you meet your future spouse online, you have more marital satisfaction. Okay, it's 2013. It's an interesting way of thinking about it. So here we have people, respondents, A, B, C, and D. Two of them met their future husbands and wives, or wives, online, A and C, and B and D met the future spouse in the usual way, in the gym or doing laundry or going shopping or whatever. And then, of course, they were asked to judge how satisfied they are in their marriage. Now, see what you get here, that if you met your spouse online, your marital satisfaction is relatively high, right? 6.2, whatever that scale is. And if you met your spouse in the gym, not online, offline, then your marital satisfaction is kind of low, all right? Or at least it's lower than this one. Okay? Okay, quickly. Who can tell me what the predictive variable is here? Where people met. Very good, Rita. So what are the two meeting? What are the two levels? Beautiful, Stephanie. Exactly. You either met your future spouse online on cupid.com or whatever, or you met your spouse offline. What's the response variable? Who can do that? Marital satisfaction. Beautiful, Louis. Fantastic. Yeah. Okay, good. So now looking at this, who can identify the type of the predictive variable? That is where people met. Is it continuous? Is it categorical? And what is the scale that you will measure it on? Categorical, yes, because the levels are online, offline, right? So what's the scale? Nominal, yes, excellent. So now let's look at the response variable, that is marital satisfaction. Okay, what are these levels? What are they? Is it a categorical or continuous variable? Nominal, continuous, very good. And the scale will be, again, the way Siver and I had this discussion just a few minutes ago, it could be a ratio if you say that there is such a thing as no marital satisfaction at all, measured as zero. But remember, whenever we have scales created by psychologists, it's almost always interval. Yes, thank you, Luis. But in terms of statistical analysis, it doesn't matter. All it matters whether it's categorical, names, or continuous, numbers. So now we have a we have a second scenario where the predictive variable is categorical while the response variable is continuous. And that's different from the first two. So here, again, if you continue to think about it, you will start to understand that this cannot be a scatter plot. Because, well, how are you going to plot online, offline? Right? Because if you plot things that are numbers, right? That's what we did for the first two. Well, you can see at the graphs, you can see what these X and Y axes look like. These are numbers. But now one of them is online, offline. How are you going to do that? Do you see what I mean? Why it is strange? It cannot be a scatter plot because the predictive variable is not continuous. It's categorical. Well, one would say they actually did that in the textbook. This is what it looks like, and looks really strange, right? Because these are names. You can't, and their names, they cannot be arranged on the number line the way the scatter plot normally works. So now it looks kind of strange. Or you could say, well, the pink dots are kind of higher than the blue dots. But that's, again, this is not what we would normally do. So although for the first two cases, continuous, we had scatter plots and correlations, that could be linear regression as well. Here, we will have to do something different called a t-test. A t-test compares two means. There's a mean here, which is about 5.5 or something like this. So that's the mean. So if you meet your future husband or wife online, then your marital satisfaction is 5.5. If you meet your future spouse offline, your marital satisfaction is going to be a bit lower. Let's say 5.1. So what the t-test does, it compares these two means and tells us, I'm simplifying grossly, whether they are the same or different statistically. Numerically, of course, they are different, 5.5 versus 5.1. Jeremiah, we're not doing any politics here, okay?
I know it was the wrong chat. I had another message that popped up.
Mm-hmm.
Sorry.
Well, let's focus on bivariate correlations, Jeremiah, okay? All right, so we don't even represent, so when your predictor variable is categorical and your response variable is continuous, you're not doing a scatter plot and you're not doing a correlation, you're doing a bar graph and you're doing a t-test. So for now, as you can see, here is the mean of about 5.5 here and about 5.1 here. And this difference assessed by t-test would be significant. Let's assume, I don't know, I'm just saying. And it looks like if you meet your spouse online, you will be happier in your marriage. That's what the study tells us. So again, for everything that you will have to do in your future psychology career, your other classes, when somebody asks you in your 266, your first step is always to identify the two variables, identify which one is the predictor, which one is the response, then go through the steps. Is it categorical? Is it continuous? Okay, you don't even need to worry about scales that much, as long as you know which one is categorical, which one is continuous. But to know that, you have to think of numbers versus names. And then you just go through this categorical, continuous, categorical, continuous, categorical. Somebody would want to tell me, not necessarily now, at some point, how we would analyze that other. So categorical is your assignment too. And even though we haven't done data analysis, I already said it 300 times, that when we have two variables that are categorical, we are going to do chi-square. So there's only one left when the predictive variable is continuous and the response variable is categorical. What kind of statistical analysis do we do that? So the answer to these four questions is your entire 266 in a 5-minute, in a nutshell. Okay, if you learn that, you'll do well. Listen to me, I know what I'm saying. All right, in the remaining time, which we have about 15 minutes, let's repeat again. That's a summary of statistical analysis. Your test depends on the types of two measured variables. Is your predictor variable continuous, categorical? Is your response variable continuous or categorical? then there's absolutely no mystery which analysis to do. And how to do it, who cares? You have SPSS, it will do it for you, as long as you give it the variables. Okay, so if both are continuous, a scatter plot and correlational analysis with R coefficient. If categorical and continuous, a bar graph and a t-test. Of course, if you have more than two means, if you have three levels, then it's not going to be a t-test, it's going to be an analysis of variance. All right, let's just spend a little bit more time on how we would interrogate association claims. Okay, we're sort of beyond assignment 1 at this point, but the questions remain. So for association claims, we are doing 3: construct, statistical, and external. And external is less important, as we know, because we always work with samples anyway. Let's talk about construct validity for just a minute. This is a different example. Here, the example is, what will happen if you're a mother, if you go and work? Will your child be less academically successful if mother is outside of the house versus children whose mothers are housewives, so they spend time with children in the house? So you need to have an operational definition, right, for each of them, and then you would have to think about the validities. So here is an operational definition of maternal employment. Mother reports to the experimenter that she is employed, or she was employed when the child, from the time the child was born until the first 3 years of life. And achievement could be measured on different instruments that people use. So for example, there is a particular test called PPVT, Peabody Picture Vocabulary Test, that gives us the vocabulary knowledge of a child. And the highest is 100. So it's sort of scaled like a 0 to 100. So will a child's vocabulary be dependent on whether mother was at home with the child and read books to her and took her to museums and blah, 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 versus when the mother was employed and the child went to a daycare center? So these would be these two variables. And you have to say, what's the construct validity here? Well, if the mother says that she was employed, if she is that a valid way to measure employment? Well, sure. We assume that she is not lying to us. Achievement, if it's vocabulary, perhaps PPVT is a good way of doing that. If it's about IQ, maybe we need a different test. Okay, so that would be the construct validity. Do these variables, well, are these variables measured the way they should be? Do they represent what they're supposed to represent? Maternal employment and child's academic achievement. But again, we've talked about that when we talked about chapter 3, so I'm not spending more time on that. I want to move on to stats. This is not about doing stats. This is about thinking what stats do for us. Okay, remember we just a half an hour ago, we talked about our values, actually our strengths. And the way to do that is to use Cohen's D table, because we care about the effect size. That is, how strong is the relationship between the two variables? And when the effect size is large, we are making more accurate predictions. That is, we will say, for quality of conversation, the deeper the talk, the more happy you are, because it's 0.28. For multitasking stuff, the more you're engaged in multitasking, the less accurate you are, but this relationship is much weaker. So maybe it depends on the type of media that you're combining. And also, these numbers tell us how important the result is. So the stronger the effect, the more important the relationship between the two variables. Okay, so that's the first part of statistical validity interrogation. Presumably, those of you who read your research article for assignment 1 well should have gone through this, because you have to assess statistical validity. That is a separate story, because validities were not an easy part for you. All right, here are the questions. So I just addressed the question of the effect size. The second one is, how statistically significant is this R? Is this difference? All right. This is something that you will spend a lot of time in 266 on. Spend a lot of time on this in 266 because you will always have to calculate what we call a probability. Now remember that what we're doing, we are drawing samples out of populations. And then we do a statistical analysis where we say that our finding applicable to the sample will be extended to the population. That's why it's called inference. It's called inferential statistics. And this P probability tells us how likely are we to make a mistake. And mistakes could be of two types. You can either say there is a significant difference when there isn't, or you can say there isn't a difference when there is. These are called type 1 and type 2. Type 1 is much worse than type 2, and this P gives us the chance of making such an error. Again, not that I'm asking you to understand all of that, because I know this is ahead of you in 266. But when you read an article, which is what you will be doing for your assignment 2 now, there will be statistics in that article. So you need to understand whether they found this difference and whether it was statistically significant. So again, the textbook appendices has a section on that if you want to read that and learn a bit more. Again, I'm not insisting on that because you are still a bit before 266. But however, the piece of advice, if you can, depending on your life situation, do not postpone 266. That is, you're finishing 201, assuming that you're going to get a C or above, go straight into 266. Again, here is another way to think about this course. We know that there's a very strong correlation between the grade that you receive in 201 and the grade you receive in 266. The longer the time between the two courses, the worse your performance in 266 will be, because you will start forgetting the stuff from 201. All right, here is the way it will look like in an article. This is again Mel's article. This is what's called a correlational matrix. Whenever you see a star, right, that means that this is statistically significant. All right, and we know because we looked at Cohen's table that anything 2.2 and above is a small effect, but it's there. Whenever you see 2 stars, right, here's 2 stars. Do I teach 266? Oh, Rita, why? No, I teach labs. Of course I can, but I don't do that. If anybody is interested, who I would suggest as a your statistics instructor, email me privately and I'll tell you who is the best person in our department to teach statistics. 2 stars means that the effect is even stronger. Do we have any 3 stars, which is possible? No. So you would say you will take this variable, talking to others, we didn't discuss any of that, and satisfaction of life with life, right? This would be a negative correlation between these two. Oops, I'm sorry. Yeah, in the wrong place. Let's kill that. Talking to others and satisfaction with life. Okay, it's a positive correlation, meaning that if you talk to others, you're being social, you're going to be more satisfied with life. And here is our small talk and happiness. It's a very weak correlation just by itself. A percentage is much stronger. So the more small talk you engage in, the less happy you will be. That's what these numbers mean. So you're going to go through this table and you will look at these correlations paying attention only to the ones that have stars to them. Good. Let's finish statistics in a few minutes. Validity 3, okay, depends on whether you actually have subgroups in your data. It's possible that you recruited people in such a way that some of them sort of belong to one group and the other people belong to another group, and you didn't know that. Let's say I'm going to go about and recruit psychology students. I may just get some seniors and some freshmen. Okay, these guys will be very different in their performance, but I didn't pay attention to that. So I may lose my statistical validity because the two effects will cancel each other, right? So presumably seniors will do much better than freshmen. So we need to be able to then use it as a moderator. You guys read about it, and do statistical analysis in such a way that each groups are analyzed separately. Outliers, okay? Outliers are these data points that are way above or way below our regression line. So the regression line here is going to be something like this. So as you can see, all these dots, data points, are kind of close. Even the ones that are sort of lower, but they still kind of close, because if you measure this distance, right, and this distance, you can see that this one is twice as high as this one. So by taking away out, we can either see, we will see the effect of taking out an outlier. That's why we do a lot of data cleaning when we get our data, not in your case, but these extreme scores can pull our analysis to the point that it becomes non-significant. We would like to have a sample that's sort of coherent, that doesn't have these outliers. All right, and 2 more questions and we are done for today. Restriction of range, I don't even want to talk about it. It's not something that you guys will ever need to worry about. Okay, and actually the last one I thought, did we miss the last one? Association, restriction range. Oh, is the association curvilinear? That's going to be number 5 that I did not put on the slides. So number 5 is the curvilinear relationship. What does it mean? Well, if you have your scatter plot like this, if your data pattern like a U shape, right? It's curvilinear because it curves twice. That can wreak havoc on your statistics to begin with. And we sometimes get that. If you think about, this is my last example. Yes, there would be 3 stars, Stephanie, if the relationship is around 0.8, if we are talking about R. So think about how we use healthcare in general. So when we have babies, right, we take them a lot to see the doctors. Well, they have vaccinations, well baby checkups and stuff like that. Then when we are sort of young and middle-aged, we're doing okay. We don't go to the doctor as much as we have to. And when we get older, so this is, let's say, before the age of 3, and this is, let's say, the age of 70 or something, where people start going to the doctors a lot more, then you're going to have a curvilinear relationship. So what we haven't done is the internal validity, and that was actually your assignment 1. We'll see. If we have time, we'll talk about it on Thursday. Okay, guys, thank you for being with me today on this day. The class is over. If somebody wants to ask me a question, stay behind. Otherwise, go and be anxious. You too, Jasmine. Take care, Didi.
Hello, Professor. I have a question.
1 second. Go ahead.
So, so my group, we've done observations,
Uh-huh.
and we sent it to you. You've approved it, but we did kind of like a test, like a test run, and we
It's called a pilot. Vanessa,
pilot.
which group are you?
5,
Group 5. Yeah.
and we did like a pilot test,
Mhm.
and it went out pretty well. Like I went to the bridge, and I saw like a lot of people like
Walking in the bike lanes,
yeah,
right?
it was kind of insane. Um,
Mhm.
and I was wondering if I could use the pilot's results because we use the same Excel sheet for it. And
How many? Yes, you can, as long as your parameters that you are going to use for your actual observation are the same as your pilot. That is,
yeah, they're
let's
the
say
same.
you're observing people for 15 minutes or whatever it is. If it is the same, that's fine. You can certainly do that.
Oh, okay, awesome. Because like just a lot of stuff was going on the day that I went. It was kind of insane.
I can imagine. I understand. So as long as like I said, your parameters are the same, you should be fine. So
Oh, awesome.
go ahead and include your pilot data.
Thank you.
You're welcome. See you on Thursday.
See you on Thursday too.
Professor, I have a question.
Hey, Rita. Okay. Jeremiah, is your question quick or long? Should I talk to Rita first?
Talk to Rita first.
Okay, Rita, go ahead.
So I just looked at my grades, and I think for the activities, the discussion boards, my grades are wrong. I don't know. For September 1, 2, 3, my grade is 1 out of 3. I don't know. It's out of 3.
So here's the problem. There was 1 week where I think it was the week of October 1st, where it's not posted on the discussions board as a forum, because I did not assume that anybody would be doing anything but finishing. So what is important, Rita, and you can do that for me, you can go to your discussion board, to all your forums, and just calculate the number of entries that you have made.
Okay.
Okay? So remember that in the beginning, which I don't do anymore, I was looking at how correct you were. So potentially you've lost maybe a half a point or a point somewhere, but I will be happy to give them all back to you. So because you're doing it versus people who I can't, no matter how much I say, do your activities. So if you give me the number, I can tell you what I have now. Let me just go to my Excel. All right. Where's my Excel with the grades? I did grading today, so I certainly looked at them. Okay, and I'll tell you what I have. 2, 1. Okay, Rita. Okay, so this is what I have. If you write it down and then check. So September 7th, 2, 14th, 1, 21st, 1. I have nothing for 28th of September.
I didn't post anything.
Okay, and then I have October 19th. So see, there is that gap. October 19th is 2 and October 26th is 3. So at this point, what I'm looking at is 10. So when you go and check your discussions, if you have more than that, just let me know and I will adjust it. At this point, I'm happy to give you all the points. But it has to be at least 1 entry for each point. Okay.
Yeah. Okay. Because I got confused that for October 22, it was 2 out of 4. I was like, why is it 2 out of 4, not like 2 out of 2 maybe? I don't know.
See, it's the way those forums work is crazy. I should have done it as blogs. In the blog, you can say the entire class. Well, let me actually stop